Bismillahirrahmanirrahim. Assalamu alaikum, grade 6. Hope so you all are fine by the grace of Allah Almighty. Students, in our previous lecture, we have completed question number 6 to 9. Or now start question number 10, that is give an example of a number which is part number 1 is divisible by 7 but not by 14. So we have to find that number which is divisible by 7 but not by 14. Students, here we can see that the first three multiples of 7, that are 7, 14 and 21, and also first three multiples of 14, that is 14, 28 and 42. So here we can see that the number 21 is that which is divisible by 7, but here is not any number 21, which shows that 21 is not divisible by 14. So student, we will write the solution as the number that is divisible by 7 but not by 14 is 21. Now part number 2 is divisible by 5 but not by 15. We have to find that number which is divisible by 5 but not by 15. Now here let's see first 5 multiples of 5 and first 5 multiples of 15. First 5 multiples of the number 5 is 5, 10, 15 and 20. And first 5 multiples of number 15 is 15, 30, 45 and 60. We can see here the number 20 is divisible by 5, but here is not any number 20, which means that the number 20 is not divisible by 15. So students, we will write the solution as the number that is divisible by 5 but not by 15 is 20. Part number 3 is divisible by 3 but not by 6. So we will find that number which is divisible by 3 but not by 6. Now students, here you can see that I have written it here first 3 multiples of the number 3, that is 3, 6 and 9, and also first 3 multiples of the number 6, that is 6, 12 and 18. Here we can see that the number 9 is divisible by 3. Here is no any number 9. So it means that the number 9 is not divisible by 6. So students, we will write the solution as the number that is divisible by 3 but not by 6 is 9. Now move towards the question number 11, that is test whether 6 is a divisor of part number 1 is 504. Now students, let's take a review for the test of divisibility of digit 6. The digit 6 would be divisible by the number if and only if the number is divisible by 2 and the sum of the digits of the number is a multiple of 3. For example, you can see here 54. The digit 4 represent that this number is divisible by 2, and also the sum of the digits of the number is a multiple of 3. So let's sum up the digits, that is 5 plus 4 is equal to 9. The result 9 shows that this number will be divisible by 6. So now solve question number 11 and part number 1. So here is part number 1, that is 504. Let's check either this number is divisible by 2 or not, and then we will see that the sum of the digits is either multiple of 3 or not. If both conditions satisfied, then this number would be divisible by 6. As we can see here, at unit place the digit is mentioned even number, so it represents that this number is divisible by 2. Now sum the digits and let's check the result. 5 plus 0 plus 4 is equal to 9. As we can see here, 9 is a multiple of 3. So both conditions are satisfied, which means that 504 is divisible by 6. And students, we can see the solution is according to the divisibility rule for digit 6. 504 is divisible by 2 as at unit place the digit is 4. We can see here at unit place the digit is 4. Also 504 is equal to the sum of the digits 5 plus 0 plus 4 is equal to 9, which shows that the sum of digits is multiple of 3, as we can see here. Hence both conditions are satisfied, which is 504 is divisible by 2 and 504 is also a multiple of 3. So we can see it as by divisibility test 504 is divisible by 6. Students, part number 2 and 3 is in your homework. Move to the part number 4, that is 4510. Let's check either this number is divisible by 2 or not. We can see here at unit place the digit is mentioned 0, which shows that this number is divisible by 2. Now let's find the sum. 4 plus 5 plus 1 plus 0, which is equal to 10. So here is the result 10, which shows that this is not multiple of 3, as first condition is satisfied but second is not satisfied. Hence this number is not divisible by 6. Students, here you can see the solution, that is according to divisibility rule for digit 6. 4510 is divisible by 2 as at unit place the digit is 0, we can see here. Now sum the digits and the answer is 10, which shows that 10 is not a multiple of 3. Hence the number 4510 is not divisible by 6 as second condition is not satisfied. Now move to the next question, that is question number 12. Test whether 9 is a divisor of 207. Now students, let's take a review for the divisibility test of digit 9. That is, the sum of the digits of the number is a multiple of 9, then that number would be divisible by 9. It means that if we sum up the digits and the answer is in the multiple of 9, now sum up the digits and let's find either this number is divisible by 9 or not. By adding the digits 2 plus 0 plus 7, the answer is 9, which shows that this is a multiple of 9 and also the number is divisible by 9. Here is the solution, that is according to divisibility rule for the digit 9. Sum of the digits 2 plus 0 plus 7, that is equal to 9, which shows that the sum of digits is a multiple of 9. So 207 is divisible by 9, or we can write it as 9 is a divisor of 207. Students, part number 2 and 3 is in your homework. Let's move towards the part number 4, that is 3655. So here is part number 4, that is 3655. Let's sum up the digits to find either this number is divisible by 9 or not. 3 plus 6 plus 5 plus 5. We can see here that the sum is equal to 19, which means that this number is not multiple of 9 and also the number is not divisible by 9. So students, here is the solution, that is according to divisibility rule for digit 9, 3655. When we sum up the digits 3 plus 6 plus 5 plus 5 is equal to 19, which shows that the sum of digits is not a multiple of 9, so 9 is not a divisor of 3655. Students, we have completed question number 10, 11 and 12. Now move towards next concepts. As about prime numbers and composite numbers, I have already explained in the previous lecture. Let's take a review and a little bit explanation. Start from even and odd numbers. Students, you can see here is the definition of even number and it is already highlighted. That is, a number which is exactly divisible by 2 is an even number. For example, 0, 2, 4, 6 and 8 are even numbers because these numbers are exactly divisible by 2. The divisibility test proves that any number ending with 0, 2, 4, 6 or 8 is an even number. If in any number the last unit place is 0, 2, 4, 6, 8 and so on even numbers, then that number would be divisible by 2, as we have already studied in divisibility test. Next one definition is about odd numbers. That is, a number which is not divisible by 2 is an odd number. Any number ending with 1, 3, 5, 7 or 9 is an odd number. This is just opposite to the definition what we have studied about even numbers. Next one is prime numbers. As we know that prime numbers are those numbers which have only two factors, 1 and itself. Here is the definition given. A natural number that has only two distinct factors, namely 1 and the number itself, is a prime number. The smallest natural number is 1, as we know that natural numbers start from 1, 2, 3, 4, 5 and so on. Hence the smallest natural number is 1, is not a prime number. The digit 1 is not a prime number because 1 multiplied by 1 is equal to 1. Here are the two factors of 1 but the factors are same. Now students, let's take some more examples. You can see here the factors of 2 are just 2, 1 and 2, 1 and itself. This means that the number 2 is a prime number, and the factors of 3 are 1 and 3, 1 and itself. We can say that this number 3 is also a prime number, and the factors of 4 are 1, 2 and 4. This is not a prime number because it has more than 2 factors, and the factors of 5 are 2. This means that 5 is a prime number. Factors of 6 are 1, 2, 3, 6. This is not a prime number because it has more than 2 factors. And for the digit 7, the factors are 1 and 7. This is only just 2 factors, which shows that the number 7 is a prime number, and so on. So from here, the digit 2, 3, 5, 7 are prime numbers, as this all contains just 2 factors, 1 and itself. Students, have you noted that the digit 2 is even number and also prime number, but the onward prime numbers are 3, 5, 7, 11 and so on. The onward prime numbers are odd numbers, but the digit 2 is only even number, that is prime number. Students, instead of 2, 3, 5, 7 numbers, the numbers 4, 6, 8, 9, 10 are not prime numbers, as it contains more than 2 factors. Hence, they are not prime numbers. Note that 2, 3, 5, 7 are 4 prime numbers less than 10. Next, move towards composite number. Here is the definition given. A number which has more than 2 factors is a composite number. The number 4 has 3 factors, as we have already studied, that is 1, 2 and 4. It means that the number 4 is a composite number. Now students, we can see here that natural numbers can be divided into different sets, odd numbers and even numbers. As we know that odd numbers are 1, 3, 5, 7, 9, 11 and so on. Even numbers are 2, 4, 6, 8, 10, 12 and so on. These are the sets of natural number including the digit 1, and now moves towards the division of natural numbers excluding 1, that is prime numbers and composite numbers. As in prime numbers, the numbers are 2, 3, 5, 7, 11, 13 and so on. And in composite numbers, the numbers are 4, 6, 8, 9, 10, 12 and so on, as it contains more than 2 factors. Now, what is the difference between odd numbers and prime numbers? As we can see here that 9, 15 and 21 are odd numbers but not prime numbers because it contains more than 2 factors. 1, 3, 5 and 7 are odd numbers and prime numbers as it contains 2 factors. Next question is, what is the difference between even numbers and composite numbers? Let's see here. That is, 2 is an even number and a prime number but not a composite number because 2 has only 2 factors and it is a prime number. It is the only prime number that is even. All the other prime numbers are odd numbers, as I have already explained. 4, 6, 8, 10, 12, 14 are even numbers and composite numbers because it contains more than 2 factors. Students, this was all about prime numbers and composite numbers. Just keep it in mind that prime numbers are those which contains only 2 factors, 1 and itself, and composite numbers are those which contains more than 2 factors. Now students, move towards our next concept, which is most interesting, the Sieve of Eratosthenes, that is the Greek mathematician Eratosthenes, 194 BCE to 276 BCE, devised a very simple method of sorting prime numbers less than 100. The method is known as the sieve because it is analogous to the method of separating the chaff from wheat through a sieve. Let's see here. We can see here is a table. This table is called the sieve, and the various steps to sort the prime numbers from 1 to 100 are given below. How we can find the prime numbers from 1 to 100, which one is included? That is part number 1. First of all, in order to find, exclude the digit 1 from the list. So the digit 1 is excluded from the list. We can see that the numbers are started from the digit 2. It is not a prime number, as we know that the digit 1 is not a prime number. Part number 2 is start with 2, mark it as the first prime number. Here we can see that the number 2 is already marked in the form of this circle. Cross out all the other multiples of 2, I dot e every alternate number, and then cross out the every multiple of 2. Like here we can see that the digit 4 is crossed, digit 6 is already crossed, and 8 is already crossed. Multiples of 2 in this given box is crossed. Part number 3 is mark the number 3. Now let's mark the number 3 that is already marked in the form of this circle. Cross out all the other multiples of 3 and then cross out all the other multiples of 3 that are, as we know that 3 2s are 6, 3 3s are 9, and then onward marked cross to the multiples of 3. Note that some of these numbers have already been crossed out as multiples of 2. We can see here that if the multiples of 3 is present in the multiples of 2, that has been already crossed, then do not cross that digit 2 times. Fourth part is mark the number 5. Cross out all the other multiples of 5. Now mark the number 5 in the form of circle and cross out all the other multiples of 5 as 5 2s are 10 and that is already crossed. 5 3s are 15 and it is already crossed. Note that some of them have already been crossed out as multiples of 2 or 3. Multiples of 5 may be crossed out which are already the multiples of 2 and 3 and that has been crossed. Part number 5 is mark the number 7. Now mark the number 7 and cross all the multiples of 7. Cross out all the other multiples of 7. Again note that some of these multiples have already been crossed out as multiples of 2, 3 or 5. It may be the multiples of 7 also present in 5, 3 or 2 and that has been already crossed. And now these are the prime numbers from number 1 to 100. So we can easily find the prime numbers by this method and by following these rules. And this is not difficult, it is quite easy. Just mark the digit 2 and then cross the multiples of digit 2. Mark the digit 3 and then cross the multiples of 3. Mark the digit 5 and then cross the multiples of 5. And also mark the digit 7 and then cross the multiples of 7. Now the sieve reveals the prime numbers between 1 and 100 that are started from 2 and ends at 97. Now here is the new concept, that is twin primes related to the prime numbers. Twin primes are pairs of prime numbers with a difference of 2. So let's understood what does it mean. We can see here that if you take difference of 3 and 2, then the answer would be 1. If we take the difference of the prime numbers 5 and 3, then the answer will be 2. And if we take the difference between 7 and 5, then the answer is 2. The prime numbers which shows difference of 2 makes a pair like this: 3, 5, 5, 7, 11, 13, 17, 19, 41, 43, 71, 73 and so on. This contains the difference of 2 and that is why it is called twin primes. Now let's move towards the prime triplet. A set of 3 successive prime numbers, the numbers differing by 2 forms a prime triplet. As we can see here, the difference of 5 and 3 is 2. 7 and 5 is also 2. And then the difference of 11 and 7, then it would not be 2. So we can see here that the only known example of a prime triplet is 3, 5 and 7, as their difference is 2 and also the elements are 3. That is why it is called triplet and these elements are prime numbers. That is why it is also called prime triplet. Students, here is a box that is, do you know? So let's see what every even number greater than 4 can be expressed as the sum of two different or prime numbers. It means every number which is greater than 4, we will write that number as the sum of the prime numbers. That is, if we can see here, the number is 8 and it is greater than 4, and we can write 8 as the sum of prime numbers. The sum of prime numbers included 3 plus 5 is equal to 8. Next one example is about 12. We can write 12 is equal to the sum of prime numbers that are 5 plus 7, and also 18. Let's see about 18. We can write it as the sum of the two prime numbers that are 7 plus 11, and also we can write it as 5 plus 13 which is equal to 18, and 34 is equal to, we can write it as 3 plus 31 and also 11 plus 23, as these are the prime numbers and their sums will be equal to 34. So let's think about 44, 56 and 80. What would be the prime numbers that we will add to make 44, 56 and 80? Okay students, to practice of question number 11 part number 2 and 3, question number 12 part number 2 and 3 also. Do practice of this question 10, 11 and 12 and understood all the concepts, and also learn the definitions of even numbers and odd numbers, prime numbers and composite numbers, and also about twin primes and prime triplet. Okay, best of luck. Stay home, stay safe. Allah Hafiz.